Okay, ma'am. So we are live right now.
Okay, fine.
Good evening, everyone. Welcome to another session with Voyages into the Past. I am Anirban Ghosh, is with you, and once again, welcome to our first episode of the lecture series about dating science in archaeology. Our today's topic is Quaternary Dating, a retrospective study, and we are really glad to have Miss Miriam Collins with us. So, ma'am,
Thank you. Yeah,
hello, ma'am,
thank
and
you.
welcome to Voyages. Miss Miriam Collins is the founder of Emotion Makers and specialized in forensic archaeology and quaternary studies. She has studied archaeology, museology, and ancient Indian history from M.G University and completed her master's in archaeology from Kerala University. She also holds an MA degree in theatre and performing arts from Kerala University and in archaeology and ancient Indian history and culture from Deccan College of Post Graduation and Research Institute. She has participated in many exploration and excavation right now from 2013, from 2013, about 7 excavations and 11 explorations. She was also associated with PAMA and had done projects with Sahapedia. She was involved in UNESCO documentation and koodiyattam. She has also conducted several workshops and talks on archaeology, heritage, and cultural management programs, as well as heritage works across the Kerala. She was also involving in teaching activities. So it was really great pleasure to have her with us. So, ma'am, now the stage is yours. Please start.
Sure. Sure. Thank you. Thank you for a very detailed, detailed report or like detailed stuff about me. I'm so happy that you are saying something, and I'm really happy to present the series of talks or the series. The very first, which I'm dealing today, is about the quaternary dating techniques, a retrospective study. So here, and I think I'm okay. If everyone is okay, I'm gonna turn off my camera, and it is
Yeah,
better
yeah,
that you
sure,
can
ma'am.
listen to you can look
Yeah,
on
ma'am.
to the presentation a little detailed. So I've made it in a very detailed, minute way, so that you can understand a very common people who is not in the field of archaeology can even understand what dating is. So I'm really going back to the presentation, and I'm posing myself to the audio, sorry, video. So I would like to say very basic about what dating is. So, for example, what we archaeology is to us, like archaeology is a branch where we are studying about our past, and that too a material culture with the help of material culture. So the study of this human past to understand their activity, their every steps is like what they have done and what they have done so far, and all we have to study in a sequential order, in a very sequential order, to understand or to place that events in a sequential order or like in a chronological order. We should know about the cultural process, and for understanding that particular cultural process we use dating techniques. So this dating techniques is like whatever objects we used to get. For example, we used to get both from exploration as well as excavation in an archaeological way. We used to get about artifacts, like those are like inorganic and organic. So we have to date that artifacts using scientific technologies or scientific techniques, and also with non-scientific techniques are also there. So this is what we'll be studying here, and today I'll be focusing more on the quaternary dating. Like we do have two types of dating mainly, which is the relative dating, which means we relate with one to another. For example, we studied a lot about relative dating even from the smaller classes. Like an example is Akash is 5 years older than Shruti. This is one thing. We relate with one person to another. And the same way, we the archaeological cultures or the cultural process with one place to another or with one period to another. That is what relative dating is. And there is absolute dating, which is called we are giving a very perfect date of a particular object or particular artifact that we recover through excavation or by exploration using scientific techniques. And today I'll be focusing or I'll be giving here a talk on quaternary dating. So going into this particular quaternary dating, we have seen this is a particular photo which shows about understanding about the verbs. Verbs means layers to understand about the geological processes. So this is a very first technique that was made in geology and archaeology to estimate a date that is so old, even in a little old way. So going into this particular thing, this period, the quaternary period. So we'll be focusing in this particular lecture. These are topics which will be focusing more on the radiocarbon dating, then the dating using short-lived isotopes and long-lived isotopes. So that we'll be discussing in the later section. I'll be giving a very detailed explanation of each words and each. And about the radiometric dating that happens used or that happened during exposures, then few dating techniques using like annual banded records. So these are the dating techniques we'll be dealing today in detail. So this particular quaternary, so we do have earth, and earth, like we don't know how old is earth. Like we used to find the age of earth, which is like from about millions and millions and millions years ago. Earth is born or earth is formed from a gigantic, or it is a gigantic ball of gases which is formed from like about millions and millions and years ago. That is what we study in the geology and in a particular topic called geological time scale. So in the very long life of this earth, we have the very last part, which is called the quaternary period, or the last period, or the very recent period of the geological record is quaternary period, which is about 2.5 million years. And this 2.5 million years is having this quaternary period is divided into Pleistocene and Holocene. The word Pleistocene matlab means recent, while Holocene matlab very recent or the new. Means the very first period is Pleistocene, very next period is Holocene, which we are living in the Holocene period. And this particular period, both these periods are characterized by ice ages. Like we have seen films regarding like ice ages and all. So like there are few English movies which gives or which narrates about the environment, the flora, fauna, and all the stuffs about the ice age. So that period is considered to be Pleistocene, as well as a little prior period to Pleistocene, which we are not dealing right now. So the period which we are dealing and the dating techniques which we are dealing is the dating techniques which is based on this Pleistocene and Holocene, or the Earth's ice age. So this particular, in the whole of this Pleistocene and Holocene, or the Quaternary period, the whole of our Earth is covered with very large ice sheets. And these ice sheets are like glaciers. Both the term can be used, ice sheets and glaciers. So the period they have experienced, or the temperature they are experienced, is very low, which is very low. It's covered with huge ice or huge mass of ice. And there are very small or intermediate periods, which is after each ice ages. That is called interglacial periods, where the temperature is much warmer and the glacial stuff used to what happen when warmth or when warmer climate is there, or when they experience a little high temperature, these so-called glaciers melt down and they form a river like stuff, or like rivulets or rivers. And that period is called interglacial period, which used to happen in high altitudes and also in low altitudes, but high altitude is what we prefer most. And this particular glaciation, or this glaciation, interglaciation, or like this is a like a cyclic process, one after another. So it is a climatic change. Based on these climatic changes like glaciation and interglaciation, we are looking into, or we are studying about the Earth's history. What happened in that part of the Earth, and what happened during that part of that period, particular period. This is what we are studying and we will be discussing today, and the techniques used for that. So, like we all know, establishing a perfect time, we want to understand what happened in that Earth, what happened way back. So, for that, we used climates or the climatic changes. Usually, when climate changes happen, our Earth's atmosphere or the environment will affect. So this climatic change and the change that is caused by those climatic change affect the environment, and this is considered to be the very key element or the most important element in the quaternary research. Like this, the study of to understand about the characteristics about the Pleistocene and Holocene. So whatever, like we have to date a particular period of a geological time period or a particular geomorphological process, a particular artifact, or like we have Paleolithic culture, we have Mesolithic culture, we have cultures to understand, to date those artifacts and to arrange them in a chronological order. We are using this dating technique, like whether it is to date any object, for example, let it be a stone tool, or let it be a pottery, let it be a wood, an organic remains of an organic remains. We are dating that particular stuff and how we are dating, and that is using this particular quaternary research or quaternary tools. And the dating tools used is quaternary dating tools. So going into, I'll be giving a very small story, kind of a story is better, to understand about the development of this dating technique. So very like the early approaches or the very first approaches that happened to understand or to date the so-called past are very like, or to understand the age of the earth is from the Greek writings or like the classic literature works from Greek. The concept of infinity time is what they have said, and they were using like there on that time they were using very modern tools like the theories, steady state theories of the universe and all, and postulated very different theories. And during the post Renaissance period, in the European place, they have biblical thinkings that the creation of the world is about or around 6,000 years ago, and this is a time when the universe began and also the time when universe end, the world started. This is what the post-Renaissance biblical thinking is. But the chronology or of the history of the earth, which is what derived from the biblical studies and by the archbishop or from the research of James Ussher, is an archbishop of Armagh, and he believed that, or he published an article in 1654, and it is the Old Testament stuff, and it is said that the earth was created on a Sunday. Today today is also Sunday. So the earth was created on a Sunday, 23rd October 4004 BC. This is a date that is given in the Old Testament about the creation of the earth. So this is like the man, the living creatures, everything appeared on Friday. That is the next week, Friday they appeared. And those moments are being repeated, or these moments are stated in the Old Testaments. Those who have read well will know very well. I'm really sorry, I haven't read the Bible, so it's like quite different for me and difficult for me. So these events, the creations, everything that occurred between 2349 and 2348 BC. This is a time period where whole of this particular, the earth was formed. This was a thought. And the history, like then moving into the development, the history of the earth science was very first studied and observed by Davis on the basis of the Ussher's chronology. And he also got very respect during that time, and he was regarded as a very good scholar. But unfortunately, this wasn't a very good or it wasn't correct. So the modern geologist, like after several years, like in the 17th or the 18th century, like right from the 18th, 19th century onwards, a very, very gradual as well as a very good development was seen on the geological branch or geological studies, like the development of uniformitarianism thinking in geology happened, where they produce a very long time scale for the formation of earth and the process that they studied, or they made a chronology about the particular earth with the help of the geological processes that happened in the earth. And the observation was published in a book called Theory of the Earth by James Hutton in 1788. And it was like this was considered to be one of the very first book or to be produced with the very examples or very what to say very kind of understandings and very observations about the from geology. And they are saying that there is no prospects for an end. This is what the book says, but unfortunately we haven't know what it is going to happen. So, and the next studies was conducted or studied in the 20th or like the early 20th century, like from the 19th century onwards, where they were trying to understand the perfect geological time. Like the early attempt was conducted in a geological way by William Maclay in the work of him in 1790s, where he studied about the Niagara Falls escarpments, and he said that the age of the Earth is 55,440 years. And he tried, and based on this, again, there are a few other scientists like John Morley. He calculated the Earth with the help of the sodium, the presence of the sodium salt in the ocean, and also with the rock erosion happened on the Earth and all. And there are few studies about these particular things. And lately, in the 19th century, Charles Darwin came with his work, Origin of Species, in 1859, and he challenged Usher's time scale, all the works that the Greek, the Roman work, literature works, and everything, and he made postulated a very good theory about the evolution of human being, or evolution, not only human being, evolution of species, how the species came to Earth, what is the origin of them, like. And also, like, there are few scientists like John Evans. He is one of a very good geologist who studied and who researched on ancient and hand axes, the lithic tools. Based on that, he made a remote or very good understanding about the antiquity of this particular or the age of this particular earth or culture. And we know about Louis Agassiz. He is a person who introduced the term or the so-called Great Ice Periods, which is considered to be the birth of, or considered to be one of the most important event in modern quaternary science, which he done in 1837, and it is one of the it received a very good, what to say, degree of spectism in geology. And it is he studied not single glaciers, he studied almost most of the glacial cycles with the help of the rocks. And by the beginning of the 20th century, most of the geologists were working on these glaciations, what Louis Agassiz said, on the major four glaciations of the Europe as well as America, North America and Europe. So a very early attempt at establishing this particular glacial and interglacial chronology was made by a German geologist, Albert Pent, and he used the weathering and intensity of this erosion that happened in the northern alpine regions of Europe, and he established a very good interglacial period. So what he got is about an age of like 60,000 years was assigned to the last glaciation, and 2,400,000 years to the penultimate interglaciation. So this is what he is saying from the rocks which he studied, like geology. And the very first half century of the very first half of the 21st century is regarded or is considered to be the best period for understanding and for the studies of this particular quaternary period. And going into a little more, this particular, I'm sorry, am I audible? So this particular, the very first attempt, or about the time when the quaternary glacial chronology was being worked or was done or researched in the European Alps, the very first attempt to understand and to know about this was developed for a time scale. and that was based on the deglaciation process that happened in the very last phase with the help of the layered sediment sequence. And those are considered, these layered sediment sequence are known as VERVs. It is VARVES, VERVs. So this is the considered to be the basic, what to say, basic technique or basic, it's not artifact, but it is a basic technique that is used to understand or for the basic still employed, or like the basic thing that is employed to understand about the quaternary chronology. And the very early years of the 20th century saw a very good development techniques that is based on the quaternary science, but a little different, based on some, not verbs, but a little different, that is dendrochronology. So scientists started to understand about the trees. They know that, okay, trees produce rings. They started to identify the rings, and base research were conducted based on the rings to understand about the history. And these rings and the tree rings have a very good relationship between the climate. So the very basic of this technology or this scientific dating method is based on dendrochronology. Dendrochronology is based on dendrochromatology. So this, the photo which I showed you was Gerald D. Geer. This is a photo which I showed. This is Gerald Geer. He's a very famous geologist who was measuring the VERVs in Stockholm. So this is something. And also during the very part, or during the 1980s, like this dendrochronology became one of the most important, or it was formed, and it was developed by an American astronomer called Andrew Douglas, who worked with very simple fragments and very simple samples to understand about, like, dendrochronological samples, simple dendrochronological samples, to understand about the historical research and for climatology. They are understanding, or he formulated a relation between dendroclimatology to understand about the age. And he worked, in this particular man, that is Andrew Douglas, worked with Edmund Schumann and founded the world-famous laboratory called Laboratory for Tree Ring Research at University of Arizona in 1937, and this is in Europe. And it was until, or it was towards or the end of the 1930s that dendrochronology became famous, and it spread out to other places. Like German botanists started to work based on this, that is Bruno Huber, and he made a very good modern school of German dendrochronology, which was based on the tree that is found on the European, and he was working with the present day, or the present day stuff, or during the 1930s he was working, and most of the trees he studied and analyzed, and he made a very good cycle of very good data regarding, with the help of those trees found in European regions. So going into next, we have the most advanced technology, that is quaternary dating, which came during, or which came after the Second World War, with the help, like after, like usually World Wars happens, and Second World War is characterized by nuclear attacks. So when nuclear attacks happen, a decay process started, radioactive elements. So the discovery of this particular decay materials or radioactive elements became one of the most important things to understand about the dating. The measures were conducted, and all those things, like they are measured, these dating, these radioactive dating materials or radioactive elements are measured, and it is studied, and it helps us to understand about the Pleistocene age. And the very first work was conducted by William Libby and his colleagues for the development of radiocarbon dating, and he established a very good radiocarbon laboratory in the University of Chicago in 1948. And during 1950s and 1960s, this particular technique got into very most important technique with a very good or very recent and very increase in the developments. Like they established more sophisticated techniques, they built more new machines, they increased their what to say, like process and everything. And this is like during the 50s and all this happened. The radiocarbon dating technique got flourished and got established and got developed into a very sophisticated way. Then we have in the next dating series, that is actually uranium series and potassium argon dating, which is actually considered to be based on the effect of this particular radioactive series, that is the isotopes of uranium and potassium argon, how they are degrading from one particular thing to another particular. And like in the 70s, in the what to say, in the very last phase, or in the very other development starter, like we have cosmic rays, we have rays that comes from the sun. Based on these and based on the amount of energy that got trapped or that got within to an object and that emits from an object, another set of techniques developed, which is called thermoluminescence, fission track, and electron spin dating. And this particular dating techniques, or these dating techniques, we'll be discussing in details. Moving into the development in the 60s and 70s, biology started very good, and in the particular biology, the branch called molecular biology, which deals with the what happens within a cell, what are the process that happens within a cell, within the DNA, within the RNA, like the DNA and ribosomes and all started to happen, and studies were based on that. And in this time, the protein structures, they started to analyze the postmortem changes in protein, the what are the changes that happens in the protein structure and how they help us in dating. So this particular dating, amino acid geochronology, got developed, and it is considered to be one of the core long core technique to understand about the ocean sediments. And this technique again got a little revised, and it helped us to understand about what happened in these layers. Like there is a connection, each have a connection. And the development of this coring technique, like the coring technique that happened in this ocean cores or the deep oceans, help us to understand about what happened in the deep oceans. Like when it started, what happened in the, or who came the first in marine, or what happened in the ocean, and those things, like the ice core chronology, this particular dating technique happened. And moving into next, we have, like as I said, about the carbon dating, like carbon dating or whatever dating, it have certain period. Okay, based on this material can be dated, or this technique I used to date this particular time period. But a little development, okay, with few high sophisticated technologies like accelerator mass spectrometry, AMS, which is actually a revolutionized radiocarbon dating technique, and with the help of cosmogenic nuclear dating technique, a large number of or a very long period can be dated. And this is considered to be one of the most important creation which have high resolution chronology, and that we have done in Greenland ice cores and the ice cores in Antarctica. These are some of the various developments and innovations that we see in the quaternary scientist or the quaternary branch, which we are like this particular stuff. Okay, going into this, the various developments, or like these developments in the development of technology, the development of dating technologies in the quaternary branch by with the help of the quaternary scientists is considered to be a portfolio for this particular dating. And it is establishing not a single for a few years, it is establishing or it is giving a date for about millions and millions years. Like the Ushers 4004, like sorry, the biblical 4004 year, the Ushers year, and all have like cut out. And we are the recent advances in this quaternary dating technique with his 6,000 year old estimate for the age of the earth is like very difficult even us to like. I can't think about this particular, okay, 4004 years back the earth urgent. It's not. With the help of the geology, with the help of the quaternary science, it pushes back. It helps us to understand even what happened when the time of the earth is about to, like from the time when the gaseous ball started to condense, and it happened right from the Hadean period onwards. Hadean, it's the very first period, which is about millions and millions and millions years ago, billions or trillions, we can say, years ago, the earth formed. Till that period, we are studying, or till that period, we can study. So, what we have to understand in this dating is two terms, that is precision and accuracy. So, like whenever we want to go further, we have to think about two terms, that is quality. How to judge the quality of that particular age, how to make, like for example, we are giving, okay, when seeing some person, we can say, okay, he may be or she may be 20 or 25. This is something like a maybe. So, in order to that, we need a very precise, very correct qualitative data about this particular dating, which is accuracy and precision. These are two important points or two important terms that we see or used in the chronology or quaternary events. So to understand like earth, environment, and archaeological science, both these terms are using. For one who is practicing the dating and interpreting the dating techniques, these terms like accuracy is most important, the term. So going into the term accuracy, it means the degree of correspondence between the true age of a sample and the obtained age of from dating carbon. For example, if we have got a sample and we have got a date and it is about 4500, let's say this for example, 4500, it's from dating, and the true age of the sample is like we can say a plus or minus like 4506, 4507, or like it may plus or minus. That is what the accuracy, the degree. There is a small degree or the difference between the perfect date and the date that obtained through the dating process. That is what we call accuracy. And we do have precision. Precision is statistical uncertainty. It is when you have contaminations, like when this precision is usually a kind of bias that is given in the age measurement to understand. Like this is associated with the physical as well as chemical analysis of this particular dating. So it is actually considered to be somewhat a problematic, we can say, because there are distinctive problems that is associated with the perfect precision. We can't precisely say about this particular, okay, 4562, 2 hours, 3 days and all. Like the precision is somewhat which is related. Like when you have a lot of contamination, your precision will be, it depends, it will be very wide. And if you go deeper and deeper and deeper to understand more and more, the precision will narrow down. So this element, this measuring elements is one of the precision and quality. These are two terms which we should keep in mind when we are going further to understand about this dating technique. So going into this, to understand about this particular dating, we should or we have to know about some important terms. Like this radiometric dating is one of the most important part of this quaternary or quaternary sciences. Quaternary, as I said, this perfect sentence nomenclature. And what we are dealing is about the facts, what is the main things, what is happening in our earth, which are the basic terms. So whatever elements, like most of the elements that we have is like naturally occurring elements. We do have elements. So these elements like hydrogen, oxygen, chlorine, fluorine, lot of elements are there in this. And these elements constitute the base of this radiometric dating, and they occur naturally, and they are either stable and sometimes they are unstable. When they are unstable, they go or they undertake several processes to become stable. And these are like process, like the spontaneous changes are seen in their structures and the organization in order to achieve more stable form. Like they want to achieve a perfect form. And when an unstable atom or unstable element wants to be a stable form, and that process is called radioactive decay. That is, it takes times. So I like that happens with us also. When we don't have a job, we are not stable. When we have a job, we are stable. That is what stability. Like I guess it's to everyone. And the time or the span where we are not having a job and we are having a job is like a time. There is a space. Same wise, the unstable elements, when they want to a stable element, they have a particular like time period, and that time period is called the radio decay time period, or the process where they are decaying. And this happens with the host rocks and fossils. They are dated using this particular. So, in order to understand these particular terms or these particular what is happening inside the radioactivity or like these, what to say, radiometric quaternary dating, you should know about very few basics terms that we once studied in what to say, in chemistry classes way back in 12th, or even starting from 8th we have studied this. So to understand each and every process, it is we have to know about terms, atomic structure, about the radioactive processes. So these are the few things we should keep. Like base, the radiometric dating is based on most atomic structures or atoms or elements, and the process of becoming stable from unstable. That is radioactive process. So everything or whatever we are having, even a glass, even a pen, even this, which is constituted of minute particles, this matter. This matter contains even very minute particles, which are called atoms. And these atoms have nuclei. And I mean, nuclei means the center part. Every atom have a nucleus which have a very positive charged particles. And these positive charged particles are called protons. And they have particles which have no charge at all. They don't have any charge. And they are called neutrons. So this protons and neutrons are seen inside the nucleus of an atom of a matter. And this particular atom have shells or orbits. And they have an element, which is a third element, which is called electrons, which have negative charge. And they are very tiny particles which have negative charge, and they used to spin or revolve or rotate around this particular nuclei or nucleus. So this particular stuff like atom, like what to say, proton, neutron, and electron. These three terms or these three together are called the elementary particles or subatomic particles, which forms the very fundamental building of block of this matter. And with the development of very large particle accelerator meters and very machines, we are capable of accelerating the samples to very high speed and break down these particles. And when they break down these subatomic particles, or like when they move or like break down, we can understand what that is and how it is working and how it forms. And this is what we are or consider this is the basics about, or this forms the basic for the radiometric dating. So this forms the basic of radiometric dating. And we do, this is actually an atomic table. So we all know this is a chemistry table where we are having a lot of elements, and I'm just giving atomic number is written always on the left above, and it is here it is magnesium and it is 12. This is atomic number. And we have like, you should know the terms like atomic number and all. And we do have two family of electrons. Like we have a different group of or different group of particles like leptons and quartons. So here we have our particular member electron, which is revolving around the nucleus, is a part of the lepton family. And when their characteristic change, the particles or the family of lepton used to change their behaviors when with time. And like as I said, these electrons are revolving around the orbit. And the number or the exact amount or the volume of these amount or of these subatomic particles or volume is known as atomical orbits. And this the buildup of these atomic orbits allows scientists to explain about the physical as well as chemical properties of that particular atom, and it is the core of the chemistry or modern chemistry. So this is a thing which the He2, the 2 is the atomic number or the number of protons. This is an element and this is atomic mass number. So we do have certain things like when an atom, like for example, just say this is an atom. When an atom, like here, if this is an electron, when an atom needs one more electron, it gains electrons. These are electrons that is revolving around the so-called nucleus. If it leaves and if it gains, so it gains energy and it leaves energy. Like it leaves an electron, it gains an electron. So that is when it gains, the thing is like it can be positive and it can be negative. Like when it gains and when it releases an energy or loses an electron, it is called ions. So we have positive ion and negative ion. So positive ion is cation, that is it gives out one electron. And when it accepts one electron, it is anion. So you have the process of gaining and process of removal of electrons is called ionization. Yeah. So if this atom or if this electron, sorry, not atom, if this electron goes out, it will be positive one. If 2 electrons come in, it will be negative. If it gains 2 electrons, it is negative. It is acquiring a lot of negative charge. If it is leaving out 2 electrons, the atom is having positive charge. And the process is called ionization. And it happens or it is important in radiation. This is one of the most important things in radiation. So as I said earlier, we have seen how the writing stuff, how we are writing. So each element, every element have atomic number and atomic mass number. So how we write the number of the mass number of total, the mass number is the total number of particles inside the nucleus, that is 4 protons plus neutrons. And every atom or every element have same number of protons but different number of neutrons. That is what is called isotope. So what we will be dealing in this quaternary dating is based on this isotopes, the isotopes and the nuclides. So individual isotopes of an element is called nucleides, and most of the nucleides are stable, but there are nucleides which are unstable, and when a process happens with them, the result of that, when they are unstable, what happens is they emit particles. They emit energy to become stable. And this process is what we are studying, and this process is called radiation or radioactive decay. And the isotopes that go or that have, that undergo the process of to attain stability is called radioactive nuclide. And this is formed in 3 forms. Like there are 3 most common forms of unstable nuclide, and the energy they exist. They are alpha, beta, and gamma rays. So we are not going a lot about these rays. We'll be going, even though it is like the alpha, beta, gamma rays are like most important because the emission, it is based on the emission. And when we do have different types of atoms or isotopes, we have isotopes which are very short, like short-lived isotopes, which means They need very few years to become stable. And there are isotopes which need thousands or like hundreds of years to become stable. That is, we have short-lived isotopes and we have long-lived isotopes. So based on these short-lived and long-lived isotopes, we have divided the so-called radio or metric dating or this quaternary dating. So, when an atom undergoes a radioactive decay, an atom that undergoes, or if I'm an atom, I undergoes a radioactive decay, I'm a parent nucleide, or parent atom or parent nucleide. And what I become, like when I become stable, that is called daughter nucleide. So the product is daughter nucleide. So some parents and some daughter transformation can happen in one stage. Some can happen in like very change stages. Like one process, like one, if for example, if one for I'll say about something regarding our kitchen stuff. If we want to make some curry, what we do is we cut. That is one stage. We we'll put some other things. We'll put some other things. It's a change process. And something, if you want to make chai or something, it's like something simple. Like just boil it, put the tea leaves. That's it. Chai is made. It's kind of simple. But if you want to make it more complex, like a curries and all, it's a change process. It occurs in a very series, like a different series of reactions happens inside that, and there are chain reactions. There are chain and there are simple decay, chain decay and simple decay. And so going into the decays and all, we do have what are the elements, like the radioactive elements. Usually when they are unstable, they have to become stable, and the length of the time that is required for them to reduce a given amount of quality of a parent nucleide to a one half is called half-life. For example, if you have about 1 gram of parent nuclei and it means decay after about a time of like a half period to about zero point 0.5 grams, it will be like the time that takes to become zero point 0.5. One from zero point 0.5 is called half-life. Then again, there is a half-life. This is actually the very most important concept that the radiometric dating is revolving around, or the archaeologists, the geologists, and everyone is focusing more about. So going into the quaternary, very specific about these are the basics that you should keep in your mind when we are dealing or when we are hearing about the dating techniques. So we do have the quaternary dating, or this is considered to be the very stratigraphic framework, and we'll be giving on very some terminologies. Like we do have the quaternary, as I said, it is divided into Pleistocene and Holocene. Again, these Pleistocene do have different periods, which is based or subdivided into glacial, which is very cold, and interglacial, a temperate or warm period, or like temperate period. And this glacial is again, or these stages are divided into stadials, which is cold, interstadials, warm. So the glacial is very cold, interglacial is temperate, stadial is okay, fine, it is cool, I can be there, and interstadial is warm. This is how the periods are. These are like episodes. The distinction between, or the so-called this between the glacial and stadial is what we are studying, and it is like it took about a lot of time. It took about more than years, more than thousands and thousands of years to become from a very cold climate to a very warm climate. It have like glacial, it will have a very stadial periods, then it will have a interglacial temperature, so then we'll move into a interstadial. So this is how the episodes of this particular glacial events are. And this understanding about the climate, and that is based, we are studying the effect of these climate with the help of the rocks or geological rocks, and that branch of studies is called climatostratigraphy. The so-called branch which understands about the what happened in that during that time, what were the climate, how it affected and all, is the main what do you say main elements or main points or main part of climatostratigraphy. So we are like getting more about glacial interglacial periods or like stadial interstadial periods, their environment, their flora, fauna, everything, with the help of the deposits that happened or that occurred when an ice is there in the cold glacial period. In the interglacial period, it is comparatively or interstadial or sorry interglacial period, the ice melt. When it melt, whatever there is, it will settle in one place. That is glacial deposits. And we have periglacial deposits. We have structures. We have biological evidence got trapped inside these glaciers as well as in these lake sediments and all. The biological deposits such as pollens, vertebrates, and everything will be trapped or will be there in the both glacial sediments as well as interglacial, stadial, interstadial sediments. And they help us to understand about what happened or in that particular period, what is the fauna of that particular period, what is the flora of that particular period. So it is considered to be an indicative of a cold climate rain. So we have fossil records, we have biogenic sediments that acquires or that got settled in the lake sediments or in the lake regions and all. And this will help us to understand about the so-called or our past culture. So this is one of a shape where this ship used to go to a deep coast and they drill the ocean bed and they take the sediments or these sediments that is deposited in the ocean beds, even not the very floor. They drill it and take the layers of the rock to understand about the sediments, like macro and micro sediments, and that will help them assign what happened during that period and during that years or during that time. So we do have MOI. MOI matlab marine oxygen isotope. So this the marine the amount of oxygen, marine oxygen is got trapped in the deep ocean course, that is studied, and that is the helps understand about the events that happened in most of the places. Like usually we study MOI will be based on the northern hemisphere regions. We used to study about the marine oxygen isotope to understand about the glacial, interglacial, interstadial periods. This is one such photo which I obtained, and it is published here as a, with the help of the author. So we do have Quaternary period. As I said, this Quaternary period is also based on this marine oxygen isotope. It is divided into three mainly: early, middle, and late. The late Quaternary period is where the present interglacial last cool stage and last interglacial period, and which we have warm, cold, warm sequence. Then in the middle Quaternary period, which is about 125,000 to 780,000. That's a time period. And the process that happens is glacial and interglacial periods is studying. And the earlier Quaternary period is more than or which is before 780,000 years. So this part, like what we are measuring based on the MOI, we are dividing the Quaternary into early, middle, and late Quaternary. So going into a little deeper, we do have the very first dating technique, which is called radioactive dating. This is what we will be the very first step, the radioactive. We have finished I've said about the basic introduction that helps us to understand what is radioactive. We are taking our first step. We are just taking our first step to understand the dating technique, the perfect topic. And the radio dating was one of the most important or very first radiocarbon dating is one of the most important and one of the first radiometric technique which was developed or which was applied or which was applicable to a very short span of quaternary, which is about 50,000 years. And it was developed by an American chemist, professor, which is called Willard Lippi, after the World War II. So most of the radiometric carbon dating techniques developed after the Second World War. And here, this particular, the very first radiometric measures he took was published in 1949, and he made a book in 1942, so 1952. The book is called Radiocarbon Dating, and its second edition was published in 1955, and he is a person who got award for Nobel Prize in Chemistry in 1960. Willard Lippi, like usually this questions for those who are studying archaeology or those who are working in the field of geology and quaternary studies, even archaeology, even those who are writing the exams, they'll know that a question will usually come, who is the father of radiometric dating, like, or who, not father of radiometric dating, who is the founder or who initiated radiometric or radiocarbon dating. It's Willard Lippi, and he's a Nobel Prize winner in chemistry in 1960. And there are several works, or based on his works, there are other reviews regarding radiocarbon dating, which was published by Taylor, Brownman, then Acting, Walker, and all. And there is a specific journal also for radiocarbon, the journal Radiocarbon. They have the site, website, they have like associated links, which gives very recent developments about this radiocarbon dating and its techniques and all. So the basic principle that is behind this radiometric dating or radiocarbon dating is that this particular radiocarbon dating carbon have three isotopes: C12, C13, and C14. C12, C13, and C12, C13, and C14 are the three isotopes. And the most abundant and most common isotope of carbon is C12, which is about 98%, which is natural occurring, while the C13 is also natural, but it has very less count comparatively. And C14 is one which we have only just 10%. And this C12 and C13 are stable, while the C14 is not stable. So in order, the C14 needs to be stable. It becomes like it decays into nitrogen and it becomes stable. When it decays into nitrogen, it emits energy. And it emits energy in the form of rays or in the form of particles that we call beta rays. We had, like way back, we discussed about alpha, beta, and gamma. So when it comes to carbon emits some electrons or some energy in the form of beta rays, and it becomes stable nitrogen, N40. And this process, or like the process that happens, is called radioactivity, and which is gives the term, or which is radiocarbon. So we all know this particular atoms of carbon are formed in the upper layers of the atmosphere. Like I guess this is also there. Yeah. This particular carbon forms on the upper atmosphere, and when it interacts, like cosmic rays, these cosmic rays usually comes from the sun, and they hit the the C14, which is in the atmosphere. From the cosmic rays are coming from sun, that is very deep space, or from the long away, and they hit the so-called radiocarbon atoms. And what happen means when they hit, they want to move, or they want to become stable. And the neutron that captured or by the nitrogen atom when loses a proton and to create the C14. And the C14, when it's there in the atmosphere, so the nitrogen is there in the atmosphere already, the cosmic ray hits the nitrogen, it will create C14, and the C14 will combine with the oxygen atom in the atmosphere and forms carbon dioxide. And this particular carbon dioxide is taken by plants during photosynthesis. And this particular plants is what we are having. And this particular carbon dioxide plus CO2, carbon dioxide, dissolves in water and settles in the layers of the ocean also. So whoever, like for example, even my body have some amount of C14, that is the carbon dioxide that the plants absorb, and what I have, or look, what if the carrot I have the C14, and the carrot I have in my body, I have the C14. This is how things work. It's a cyclic process, and some amount will be there in my body and some amount will be there in the ocean. And what that is there in the ocean, and that is through the deposition of this particular what to say, this particular, the carbon 14 that got deposited in the ocean, and this acts as a storehouse. Carbon 14 acts as a storehouse for plants and animal tissues and the world ocean. So this is called what is called global carbon reserve. And we are studying here about the measurement, like how this carbon, the carbon 14, want to become stable. And this half-life, the half-life of this particular carbon 14 is 5,730 years. And the limit of measurement of C14 activity is 8 half-life. One half-life is 5,130 and it can have 8 half-lives. So I'm very bad with math, so I'm not going to calculate those things and all. So the radiocarbon measurements, or these are obtained, or we used to take when we want to have a radiocarbon dating, we want to do with organic materials, which are called biogenic materials. And they are wood, peat, organic lake sediments, plant remains, charcoal, shell, coal. These are all the organic materials which we are using for radiocarbon dating. And we are using standard materials, or we are using measurement techniques to understand, to look into how many amount of this particular C14 in this particular material, using beta counting, which is a technique, or which is a technique where we are detecting the amount of beta rays and counting the emission of beta rays that is inside the C14, and that happened during over a period of time. And this is a principle that is working in radiometric dating or C14 dating. And we have accelerated mass spectrometry, where we are giving a push, or energy, we are giving an extra energy to make the samples, to understand the samples more, in order to, we do have a time limit. In order to go beyond the time limit, we are using AMS method. So I'm not going in deep with the beta counting. It's because it is little more scientific. When I share the slide, I guess those who want, you can contact the team for having this particular slide if anyone wants. And beta counting, which I'm not going to give in a detail, while I'll show you few photos of accelerator mass spectrometry. So this particular accelerator mass spectrometry got developed in the late 1980s. And this is one of the most important events that happened in the radiocarbon or radiometric dating, where we are giving an external energy to detect the atoms. We have a certain equipment, we give external energy to that, and we are studying that particular atom. What is the function, what is the moment, how they are working, and these are what we are studying. And this particular thing is, or this particular technique, where we are giving an extra energy from outside to the carbon or to the radioactive carbon, and understand about the process that's happening within their structures, is called AMS, accelerated mass spectrometry, which we are usually calling AMS. So we had, this is one of a picture where we are getting the samples. This is an AMS machine, and all, which gives us about how the target wheels, how it is working and all. Like, see this? Like it works. It's a big machine. So this is also a National Electrostatic Corporation Accelerator Mass Spectrometry Lab in Scottish University for of Environmental Research in Central Scotland, UK. This is a photo, and this is the part of that machine. This was the part of that machine. I hope. So as I said about this extent, we know that there is a limit. Like I said, it's 5,700. It's a limit of that, and it have like 8 half-lives is what we have. So it's like very old samples cannot be dated, and if you want to hold much more, we have to use AMS. And so the extent of the AMS or the radiocarbon dating is somewhat about, we can, let's say about 75,000 years plus or minus, or like in between 50, 70 and in between 60. That is how we can term that. With the help of AMS, we can little more back about 1,000 or 10,000 years. We can move a little more further to understand the old samples. But mostly, we have a bracket about 50,000 to 60,000 years. That is a bracket of this particular radiocarbon dating. So the applications, usually this radiocarbon date tend to have errors. So the errors usually happens is like the C14 and C12 ratio in the ocean, that is global carbon reserve, which is seen in atmosphere, which is seen in biosphere, which is seen in marine water, in fresh water, and their ratio changes. That will is considered somewhat as a source of error. And also the ratio between the carbon isotope like C12 and C13 in the sample also alters. So the thing is, I am taking C12 and C13 in my body, and C14 is also there in my body. And now everything is I'm taking C12, C13, C14 I'm taking. When I'm dead, this particular C12 and C13 will stop getting into my body. And what I have is the C14 in my body. It starts to decay, or it starts to become stable. And that is what is counting. Like when an organism is dead, when any organism is dead, the amount of C14 in their body starts to disintegrate with the time period, like that is the half-life. And that death, or like the decay rate prior and since the time of death, sometimes may vary, and also the amount of C12 and C14 will also change. Will change, and that is how it is working. So that is how the particular error is happening, and error happens because of the variation in C12, C14 and C13 in our body. So going into the applications of this particular radiocarbon dating, we do have certain applications like dating techniques. For example, like as I said about the materials for dating carbon, we do have a wide range of organic materials like biogenic materials, wood, plant, microfossils, macrofossils, charcoal, peat. They are like dated stratigraphically, and they are dated using radiocarbon. And we do have certain things which are called considered to be a problematic in the area, and they are lake sediments. We have organic lake sediments where we have content of coals and coal or graphite, which have layers which have aquatic algae and all. So this particular organic lake sediments is a medium of radiocarbon, but it is problematic because the sediments that have the carbon residue or C14 concentration is different, and the deposition date is also different. So this particular problematic elements of materials are lake sediments, lake sediments, shell, same like that, the calcium carbonate and the the calcium carbonate in the shell, like the shell which is made up of calcium carbonate. S consider and the calcium carbonate or the shell, the calcium carbonate in the shell help us in radiocarbon, but it is like the terrestrial molluscus or everything will go certain process. The presence of the calcite in the shells can be understood only with the help of X-ray diffraction, and also they have to be dated. They can be dated, but it is little problematic. Even bones, like what the bones have is like two important elements. One is the bones which have cells, like cell tissues, which have fibrous proteins which called collagen, and bones have kind of minerals like phosphate. They have calcium. They have like the phosphate of calcium, which is called hydroxyapatite, and dating that hydroxyapatite, the level of the hydroxyapatite in the bone is different. I mean, it is different in different layers. So the dating is considered to be a little problematic. But when it comes to the skin, hair, leather, wood, and all, is also these are also something. But the collagen in the bone is can be accelerated and can be given more or understood more. So the calibration was made, or the calibration of this particular radiocarbon dating is made with the help of dendrochronology. The date which I got from the radiocarbon, and the date, in order to check whether it is true, what we have to do is we have to check with the dendrochronological ages that we got. So based on that, the actual and the calendar date will be very different. We all know the converting the radiocarbon date into an actual or calendar date is little difficult. So when we want to make that a very precise or very correct date, we have to collaborate, or sorry, we have to calibrate that with the dendrochronological calibration. Plus, there are other calibrations which I'm not going to discuss right now, because even it's little technical one where we are using more scientific senses in the with gamma rays and all. So moving into the so-called topic application of this particular radiocarbon dating. So there are different applications like this. Radiocarbon dating is applicable to about an object which is 40,000 years or so of the Quaternary period. And as I said about the biogenic materials, we have plant fossils like charred remains can be used, charcoal, peat, organic lake mud, marine microflora, then shell, bone can be used, and radiochronology that developed with the help of this help us to understand, or will give, or are used in archaeology, paleoenvironmental studies, paleoecological studies, and they are very good. So the very first example is like a small example of dating of a plant macrofossil, which is of the late glacial period, which help us. That is, when you date a particular, when you date this particular radiocarbon dating is done to the plant microfossils, and that too of the late glacial period. And it was a very example was done in Euphrates Valley. So it helped us to understand about the vegetation, what happened in that area, what was the vegetation, how the land was used, what was the farming activity, what is the pattern of the climate that is over there. These were studied with the help of this particular dating process of the microfauna. And like the very first AMS dating program was obtained or was done on charred cereal grains, and that too from a prehistoric site of Abu Hurairah in Euphrates Valley in Syria, which help us to understand about the inhabitants, like the hunter-gatherer inhabitants of the prehistoric period, like what they were using, what is their vegetation, what is their cultivation, what are the cereals they cultivated, and all these things we can obtain from the so-called dating the macrofauna. So the very earliest findings that we got from about the cereals of this particular Euphrates Valley and in Syria, which is southwestern Asia, gives us about the understanding about the very early cultivation about wheat and barley, and that too on the beginning of the Holocene period. And it suggests that a very systematic cultivation of ceramics started or began before the end of Pleistocene, and also is considered to be one of the first crop. That is something we are getting about the late macrofossils. Then we have dating the charcoal. It's like the charcoal. Like the charcoal is kind of something that is got preserved or got trapped, and it's like into the form of sediments, peat, and also it in the form of talusols, and also in the cave sediments. And it is one of the most important thing for archaeologists. And it helps us to understand about the ecology, the cultural information, and all. And this particular sediments are what to say, these sediments are studied, and these are considered to be the indicators of the past fire rains, and which help us to understand about the climate. As I said, what is a human activity, how the human activity is working over there. These can be studied. Like charcoal is considered to be one of the most important dating medium, and it is the date to obtain the date that is obtained by of the charcoal by radiocarbon dating is considered to be very difficult, but it is one of the most important thing. And the Holocene paleo environmental record can be obtained from this charcoal or from this charcoals, and that we have seen worked in the regions of Germany. That is one example where we have got the charcoal which is settled or which is incorporated in the tufa sediments and was dated using AMS radiocarbon dating. And we have set a chronological. We have studied using that the environmental. We have reconstructed the environmental, and with the use of these molluscan faunas, also we constructed the environment that is there in the Western Germany. Then we have peat. So this peat box, which are very rich in they are considered to be the rich, or they are the archival stuff. They are the archives. These peat are considered to be the archives of paleo environmental information. So the fossil pollens that got preserved or that trapped within the peat will help us to understand about the local and also the regional vegetations and changes, while we have the micro plant fossils or micro plant fossils. They are like, we have the wood fragments, we have the leaves, we have the sediments and all, and these help us to understand about the vegetation, how they are growing, the vegetation growing on the mire surface, on the top surface, and on the hinterlands. And these will help us to understand about a very good long-term ecological process that happen in that particular site, and what are the human activities that happen there, like how they clear the wood, how they practice the agriculture, and what is their relation between the climate. Like what is their relation between the climate? Like when you want to clear a forest, okay, they should need a climate that should be enough to clear the forest. So this is what, like, the evidence or the peat gives us a very good evidence. Like very few examples are done or very studies are done in England, in a Walton Moors in Cumbria in northern England, where a high resolution record of the Holocene paleo precipitation is taken and analyzed based on the plant macrofossils with the help of the peat profile. And radiocarbon dating is taken and is calibrated with the climate, and it helps us to reconstruct the surface wetness change or the surface wetness change from the early Holocene period to the very present day. And this revealed a very good series of wet shift, how the shift happens, the climate, how the higher climate shifted to a lower climate, how this climate is, whether the climate is cyclic, or whether what is the periodicity of this, and what is the whole of the climate around the North Atlantic region, the Greenland region, the British Isles, and all can be studied with the help of the peat, and that too from the Northern England studies. Then we have organic lake mud deposits. So just one second, I'll drink the water. So going into the lake stuff, this lake, like we do have to rate the organic lake dating of an organic mud. So the lakes are very good natural deposits, or they have like the glacial stuffs used to erode, or like when the warmer period, and they form the lake, and the sediments that are got trapped on the way are seen on the layers. So the traps and sedimentary records are seen in the lake basins, which help us to understand about the environmental, the environmental changes that happens in the lake catchment places, which help us to understand about the ecology, the paleoecology. This lake sediments is considered to be an indicator of the paleoecology, with the fossil pollens inside that, and with the macro and micro fossil pollens inside that. And this pollen records are studied with the lake sediments, colorated and studied in such a way, and it gives a detailed understanding about the particular environment, paleo environment. And so there was a studies which was conducted in Lake Rutundu in Mount Kenya, that is East Africa, Utundu in Kenya, East Africa, where 13 AMS radiocarbon dates were obtained in the lake sediments, and they are considered to be the oldest one. And they covers a region of about the glacial and interglacial transmission, what happened in the whole of the glacial and interglacial transmission period, and what happened in the whole of the Holocene period, and what indicates the lower part of the sequence, what indicates what happened in the last glacial maxima in that part of the hemisphere, and how this pollen got trapped in there. So the stable carbon isotopes and in that pollen is considered to be plant biomarker or biomarker. So this indicates that 25,000 years ago, an open vegetation was there, and a fire existed in that area, and the bush grants and the dry mountain was done. The most fire disturbed and open vegetation was around the Lake Duranta, and it got established with the radiocarbon date from the organic deposits, which dates about 25,000 to 13,400 BP. And also which help us to understand about the local vegetation, like what is grassland, what type of grassland it is, and all it helps. And then we have dating marine micropaleontological records. So this marine micropaleontological is one of the major advances in the quaternary science, as I said earlier, which got developed in the 20th century, and was the development of this technology was one of the most important characteristics, where the sediments are to be recovered from the deep ocean floors. With the help of the AMS rating, very small amount of the sample can be dated and given a chronology, or we can set a chronology even if there is a very, very small piece of sample. And this particular dating had been widely used to derive the calendrical ages of the marine settlements. And also this particular dating of the marine micropaleontological records will help to understand about the extent of the marine reservoir effect. What is marine reservoir effect? What is the extent of the climate over there? What is the oceanographic climate? What is temporal climate? and all those things can be dealt with the help of this particular radio marine micropanel or micropaleontological record. Then we have dating of a marine shell. So this was done, the dating of a marine shell was done in Mexico, which is somewhat problematic, but it was done. A shell was dated, like the inner part of the shell got dated and the outer fragments also dated. And we have got two dates, but even though it is correlated with the, it helps us to understand about the glacial and deglacial chronologies. It helps us to understand about the sea level, relative sea level, relative sea changes, and it helps us to understand or reconstruct the environmental history of the coastal regions. So study was conducted by Gardner on the marine shells in Aeolinite region in Mexican Peninsula, Yucatan, Mexican Peninsula, where he tried to understand about the physical and human dimension of dating of marine molluscus. The shells that he obtained in his studies have 4 different zones within the Aeolinite and gives a range of about a wide range, the lowest range, the middle range, and the highest range. So, and it obtained, the shell that is obtained within a small lens of the beach materials count into a very sand dunes, and which is like stone, the condition of them and all can be studied. The whole Holocene marine transgeneration can be studied, and these things can be studied. Even like the youngest date comes from the rich maiden deposits of shell, pottery fish bones, coral fragments that is on the top of the sand dunes. The date is around 25,000 pp, which provides a minimum age of completion of a sand dune formation, and it is considered to be the earliest or like an evidence of human occupation at that time. So dating of bone, like this is one thing that is related to archaeology. This is something of like one of the most problematic area in New World archaeology, which concerns or which says about the peopling of people, the spread of the African migration theory of the peopling of the spread. So we do have we know about the Homo species started or originated in Africa, or like they transformed from Africa and they spread to other parts. This is what we know. So this is a debatable thing. A number of carbon-14 datings have been done to obtain about the human activities that is associated with it. And datings were done in the Paleo-American regions. The skeletal materials have been dated radiocarbon material, and this from Mexico were dated. That is what the example over here is. Mexico is dated, and it is said that they dated the bone collagen, the carbon-14, a dating of the bone collagen, and peopling of the New World partly become increasing number indirectly and dated individual, and they fill a geological map in terms of human occupation of America at the very end of the Pleistocene period. And also the skull that indicates a very long, narrow-headed people are non-Mongolian affinities, and they was present in the Mexico regions around 12,000 BP. So with the people that came from the other regions to Mexico are considered to be established, like where the people came from and how they arrived at Mexico remain are to be established, and they are established using the radiocarbon dating. So So radiocarbon dating of other materials. This is one example which I said about the Paleo-Mexican American. A little slide shuffled. So these are the bones, or these are the skulls that got worked. So this is about 10,755 plus or minus 75-year-old, the first one. This is Tiapolco 1, which is about 10,200 plus or minus 65. And this is Textile, which is 7,480, calibrated with plus or minus 55. And this is from San Vincent Chicolopan, which is about 4,410 plus or minus 10. And this is Tepi Pixen, which is about 22,290. So these are the Texican skulls that is from Mexico region, Mexican Paleo American, which is studied. So textile. So this particular textile, dating a textile is somewhat the most striking demonstrations that is done in dating, AMS dating, and one of the earliest archaeological application of this particular technique. So the textile or as I said, the shroud of urine is about 4 meter piece of linen cloth, which is housed in the Cathedral of St. John's the Baptist in Turin, Italy, which is considered pure true burial sheet of Christ. And this is considered, and it was dated using AMS in 3 laboratories, Arizona, Oxford, and Zurich, and was accepted by the Archbishop of Turin, and it was said to be the holy shroud and all. And the Arizona dates, I should have given the dates. The Arizona date is given about 646 plus or minus 35, Oxford 750 plus or minus 30, Zurich 676 plus or minus 24. This is the date that we got of the textile, which is dated in Arizona, Oxford, and SUNY using AMS dating. Then we have dating of old documents. Like the old documents is one of the most important great advantage of the AMS, which is dating. Like for example, as I said earlier about the Shroud of Turin, this particular radiocarbon dates can be obtained on culturally valuable objects, and that of very small amount, like less than 1 micrograms or less materials can be done, and the damage to object and artifact is also therefore minimal. Like we can get about small, we can take it from that sample and date an application like AMS date is applied to ancient documents. So this is an approach that has yielded historically coherent ages. And the famous Dead Sea Scrolls have been dated. The medieval Japanese documents have been dated. And the dating was done in a Vinland map. So this is particularly considered to be the oldest map, and which is drawn on parchments and seen, or it is kept in the rare book of manuscripts library at Yale University right now. So this is in the Northwest Atlantic Ocean. The island of Vinland is discovered by the North Seafares, and like North Seafares, that is, there two are Bajran and Leif, and they are like colleagues, and it is the first non-cartographic representation of the North America, and date is important in establishing the historicity of the European knowledge or European history of the land, and that is bordering from the Western North Atlantic, or from bordering the region of the Western North Atlantic. So some scholars were arguing that this particular map's authenticity and have associated this particular map with the Council of Basel and dating the map, or they said they have to date the map and all. So dating the map, and it is dated to about half of a century before Columbus' voyage. And the convinced that this map, or this particular map, is a clever forgery, and that is, and may even date from about 20th century. The fragment of this particular fragment of the map was radiocarbon dated at the University of Arizona using AMS, and 5 individual measurements were taken, and which was like about the 1434 plus or minus 11 is the date that is obtained for this parchment, and it is through the radiocarbon dating, and the debate is going on about the authenticity of this particular map, but the AMS dating of C14 gives that this particular map dates from the Council of Bases and with which the map has been associated is true. Then we have dating of a lime mortar, which is actually done. Lime mortar, like we all know the lime, like every building, like old buildings will have lime. So dating a building, which is actually very like we have to date either wood, either the like wood means it will be of dendrochronology, like sample, and this particular dating the building, old building, initially the dating of the old building for repeated building, rebuilding, replacement of the timber, there's like some fires, younger, and everything will make the building like age much lesser. So what we can do is better we can work with the lime mortar. We can date the lime mortar. So this an attempt was made to date the lime mortar, and it is like lime mortar is what we call it as calcium CO2, calcium oxide, that is COA, and calcium hydroxide COH, and this to form the calcium carbonate. So the C14 content of this particular mortar sample gives or can give or gives us the indication of the time that has elapsed from the mortar hardening, and then the age of the construction of the building can be dated. So the dating the lime mortar is feasible to more than to 20,000 years ago. With the help of the AMS dating, a very small piece is required and the refined rapidity protocols and every procedures is done, and very development was done in the radiocarbon dating. And very successful application was made in the medieval stone church in Ålands, Finland. So this particular one, a particular mortar dating was done, which was like they collected the material in a very scientific way and dated the material in scientific. Multiple dates were obtained of this lime mortar from different parts of the church, and also from different parts means the church is very big, so there are several buildings. So it is one building is called Hummerland. They took about 18 samples. The other one is Sackwick, which they took about 4 samples, and Ehrlich, which they took again 8 samples. So the date they got is 710 plus or minus 30, and these are the date. And they calibrated the mean ages of the church, and they established that this particular church is of the like late 13th or during the very first first quarter or first half of the 14th century, like either in that 180 1300. So dating of the hair. So the dating of a hair, it's like the DNA that is extracted from the hair, either animal hair or like human hair. So this hair will give us about the information about human and versus animal, and that will be we getting about paleobiology, paleoecology, and paleoanthropology. So usually what the hair is, it is actually a protein content. We have keratin. So we used to take like now I've seen girls used to take keratin treatment for the hair, which is for enrichment. So same thing, the protein or the hair is characterized or hair have protein. And this material is extremely durable in natural environment, and it survives for a very long period, and it is one of the most important things for archaeologists as well as paleontologists, as well as it will give about the paleoecology of that particular site. And its chemical properties are very very restrained and to various processes, like radiocarbon dating of a bone and the radiocarbon dating of a human hair is very debatable. But a date was given, a date, or a particular study was done to date the hair of a Egyptian queen of a pre-dynastic period, which belongs to the early stage. So what happens is they dated that using AMS, and they dated the hair, and it became it was done and it was published by Taylor. And what they did is they studied the ancient DNA the genetic data that they obtained from the specimen, that is from the hair, and they worked on the influence of archaeology, and they collaborated with the molecular biologist, paleoecologist, and archaeologist um, about or to know about this particular DNA. And they studied this particular hair, and they went and they said that this particular hair or this the DNA identification of the hair has restricted. There is a restriction even to the model, but they've studied a study of Paleo-American occupations in the cave sites was also collaborated with these hairs, like the mitochondrial DNA was extracted from the hair, and also the same thing was conducted in other sites, like they extracted hairs from sheep, ovis, and the sample hairs from the skin using AMS. They have dated that this particular fossil hair belongs to about 9,900. So dating a hair of a pre-dynastic to dating a hair of an animal. This two different regions, like they have obtained different dates, and like this is how we are addressing a range of biological questions started to appear in prehistory. Like hair could become a fleece for prehistoric archaeologists as well as the evolutionary botanist. So this lead more questions and more things about understanding that particular period. So going into the next, we have dating iron artifacts. So this was done, like radiocarbon dates were obtained for iron artifacts, that the source of carbon is steel making process was charcoal from freshly cut young wood. So the other carbon sources we have is coke, coal, old wood, and all. So what do we do this? We just depleted of C40, and this will cause artifact to appear too old. So the possibility of using iron as a medium for radiocarbon dating has been known for some time, and it developed, like AMS developed, and we can go more into this particular thing. Like we can date the waterlogged terrestrial strides, like shipwreck strides and everything. Like a very good amount of work have been made, and laboratory methods have been improved to extract the carbon from the ancient iron and coke, which is resulted into or showing the research in relation to the dating of two iron artifacts. That is one from a nail from a medieval Japanese castle, which is about 1600, and a sword made originally in India and which was exported to Damascus, and which is about 1650. So the results using new carbon extraction method help us to understand that this iron was made between AD 1550 and 1640, that the sword was manufactured between 1640 and 1670 with about 71% confidence that it's saying, the people, I mean, the one we're saying. And the result was very good, and it indicates that they have like made a very good laboratory protocols and everything, and obtained artifact with a very correct, reliable date. Going into next, we have dating of a prehistoric. Okay, there was one dating of a prehistoric pottery was there. Sorry, I think no, sorry. Dating of a prehistoric pottery, I'm gonna say, and we will. And again, one second. So this particular pottery dating. So the earliest pottery that is dated was Japan. Ancient pottery will contain a lot of carboniferous residues. So like some of these are from older carbon incorporates that got trapped into the clay firings while the clay is fired. And there are younger materials that are absorbed onto the surface of the pottery during the time when they are beneath the salts or when they are buried in the salts. So this particular pottery, which is rich in organic rich coating, have been dated using AMS radiocarbon dating. So one is done in Nakamura, a report was established of a dating program of charge adhesives on potsherds from Odai Yamonota site in Japan, and the site was discovered in 1970. This particular what do you say? This particular pottery was discovered in 1970, and also along this, when they discovered in the site, it was artifacts, arrowheads were there, and it is a characteristic of German culture of lower late Paleolithic. So the pottery was coated in the carboniferous materials, and it is maybe it is like spoiled food or something like something like that, and it was the carbon material was extracted from the pottery, and it was dated for AMS, which was dated about in between 1268 and 1370. This was the average date. It is about mean date is like we have calibrated several dates from this. It is like in between 1571, 15,701 and 16,540. So this is considered to be the sites with ancient potteries, and we have obtained it from Russia also. And this culture is same. This culture that is in the pottery of Japan was seen in the Russian Far East also, and it began in the Holocene period. And if the dates are correct, and it suggests that the cultural phase may have been there for several thousand years. So as the time is getting more and more, I would like to stop on the very last thing, the dating of the rock art. So within few minutes, I'll give a very small. So dating of a rock art, like we can date the Paleolithic cave paintings was done, dated in Spain and France. So it was using the AMS. A considerable amount have been directed towards the dating of a rock art, including cave paintings, engravings on the shelter sites, like pictographs which are exposed on rock surface. So the thing is that in the very last, in case of the last name, the aim is to obtain the minimum age of the rock. What is engraving and the dating obtained with the associated with the desert varnish naturally occur coating that develops on rock in arid regions. And so, however, the thing is that the complex process involved in the desert varnish and organic carbon accumulation mean that the dating results have been proved to be controversial. That is like a realistic radiocarbon date determination have been obtained through very careful chemical separation of carbon-rich solids from patinas and crust overlying the rock paintings. So it was studied in a lot of sites in Altamira, then El Catino in the Cantabrian region of northern Spain, and always studied using this particular technique and identified and all. So there are other techniques which are here to understand more about the dating, which is like short-lived and long-lived. So I'll be giving a very small thing about short-lived and all. Short-lived is like something like an isotope. When it is stable, if it is unstable, it needs to be stable within a small period of time. Long-lived, they'll take a long period of time to become stable. Like if it is unstable, it want to be stable, it will take long period of time. So there are datings like Argon dating techniques, uranium series, and we have cosmogenic series, as well as there are techniques like lead. We have lead technique, cesium, and silicon. So these are the radiocarbon dating techniques which are using short-lived and long-lived isotopes dating techniques. So argon isotope dating is a technique which there are two approaches for argon isotope dating, which is potassium argon, that is decay is based the decay of the radioactive isotope of potassium. Decays or relative decay is happened with the argon isotope, and it is seen in igneous rocks. So going into a little more about this, we do have techniques like, for example, this potassium argon dating was developed by a scientist in the University of California in 1950s, and it is like the potassium decays into argon, and the half-life of this potassium is 1.3 billion years. And this method is used to date rocks which contain no argon gas. And there is one which is like argon dating, which is like the argon. There is two versions: argon 39 and argon 40. Argon 40 decays into argon 39, and it is how the dating is seen on mica, clay, minerals, and evaporates is what it is dated. So going into the next one is uranium series. Uranium dating series is same thing based on the process of radioactive isotope of uranium-238 decays into uranium-235. Uranium-235, and this is how things that uranium is transformed into another and all. And we have fission track where another dating which is based more on natural splitting of the uranium-238 ions present in the obsidian, and when they leave, they make a damage to the crystals, and that is what is called fission tracks. And studying the amount of damage that is caused to the obsidians and all is understood and dated, and that is called fission track dating. So right now, because of the time constraints, I would like to, I think it is already 7:55, about to 9, started in 6 to 9, sorry, 6 to 7, no, sorry, 8:51. So I think if there is any questions, you can ask questions about it now. And I hope I'm gonna stop over here.
Thank you for this very well explained session. And first of all, we're really sorry for the mistakes and misconsequences. Actually, ma'am, you were talking about thunderstorm, and the thunderstorm just hit our area, and there's a problem of network issues and
So it's
problems.
okay, I didn't experience it. I was like perfectly okay from this side. I didn't like even when I was having, I didn't experience like anything. Like okay, perfectly. It was no weather was perfectly okay over here. Like there is current. Like I don't know what happened. Usually there was current cut in my area, but thank God, like thanks to you that your ghost or your soul is like helping me that there is no current today. I mean, there is current today always. There is no power cut. And I'm really sorry. Since the presentation is like it's very wide, I could give a very good glimpse of only few dating techniques. There are other dating techniques also. Hope in some session, in some day, we'll be back with this dating techniques in science or dating techniques in archaeology.
Sure, ma'am. So let's move to our Q&A session. Due to the short course of time, we are taking very few questions. Okay. Ma'am, is the question is visible to you? There's the first question by Rakesh Dey.
Okay, let's the usual stages. No, but stage and the usual stage begins. There is a change in the biological and cultural perspective close to the relation between change, biological and cultural aspect established and how. Yes, Rakesh, yes, we can establish, like as you said, there is a glacial end, and for those with the interglacial, like glacial, stadial, interglacial, and interstitial. This is how the process begins. We can establish a relation between the changes of the biological and cultural aspect using climate. With the study, like pollen grains used to trap inside these layers, and they can be studied. And when you date them, or when you get the samples from the layers of these glacials, like if, for example, I'll say a very small example, that just think of a particular a rock where a few pieces of trees got trapped into. It's like not a rock, it's a ice rock with a tree got trapped. And after thousands of years, when the warm period happens, the ice melts down with the fragments of that trees moving into a particular place, and it got deposited. So we can understand that this particular tree was there in that particular period, and they were acting like, for example, just say some animals. I'm not going with the scientific name of the animals. Let's say dinosaurs. This particular dinosaurs who were there, they were having one kind of trees they were having and all. They got trapped into the ice layers. After thousands of years, they just moved into, and the thing is, they moved into, and they, like, after warm climates and all, they become, or they warm, they eroded, and they settled in some regions. We obtained that, and we studied that. Same thing, when you analyze this particular, whatever the glacial deposits, we can understand that there are some, like, for example, the prehistoric period, the Holocene and Pleistocene, the tools that we get will help us to understand that got trapped into the layers or in the sediments. When you get that, we can understand, or we can get a very good understanding about how the man used that tool. What is why they are using that particular tool? What is the relationship of that cognitive development of the man and their tools? This is how they are giving. And from this, like, for example, like, you are using a pen, and that pen, like, for example, I do love to write in a pilot pen. So that means our cognitive should be easy, flexible, and so that is the cultural as the cognitive, cultural, biological relation between the man and the cultural artifact that we are getting trapped into their glacial layers. I hope you're clear with it, Rakesh. We can establish, yes, we can establish a relation between the culture and biology, and that can be established through the artifacts or material remains that got trapped within the layers, and it can be studied using typological methods, it can be studied using stratigraphical methods, it can be studied using the so-called dating techniques. Then you can understand or correlate with the cultural and biological changes. I hope you are clear, Rakesh.
Thank you, ma'am. So here's the next question by Sharona Banerjee.
This is problems that arise in the case of radiocarbon dating. So there are a lot of problems that arise because if their calibration, like as I said, a couple of, like I've said about the error stuff. The thing is, like, the dating techniques, the problems that occurs, there are errors. There are very good chance of errors that happens with this dating techniques. So when you, like as I said, the ratio between C12 and C13, the ratio between C14 and all changes the whole dating or whole. Like, for example, if I have a C, what is give an example? Like an example, yeah, the ratio, like we do have C12, C13, and C14 in our body. So the ratio between the C10, the error used to happen when their ratio is calculated in a very wrong way. When the ratio is calculated in a very wrong way, it will become problematic. That is one reason. And that is, when there arises problems in case when the radiocarbon dating, like the problem is error problems will happen. If we are not calculating the amount of C12, C14, and C13, the problem will arise. If there is a very minute, even if, for example, the organism got, the organism, for example, the living thing got, passed away, and it was passed away a couple of, like, thousands of years back, and it got trapped into a layer of another carbon residual layer. And what happens means some of the flesh will, or sometimes we know about osmosis and exmosmosis. This is one of the main thing in biology. So what happens means some organic content will be absorbed. So the C12 or C4, 13 can be, absorbed when it is deposited in that particular layers. And when we take, it have already all, like, the count is a little more higher. When the count is higher, what happens means we are taking the sample for dating C14. The amount of C14 we calculated, and it is collaborated with the amount of C12 and C13, which is very high. Then there will be a problem. The error will happen. This is how, these are some of the problems that arise when an error happens with the C12 and C13 in the samples during radiocarbon dating.
Okay, ma'am. Here's the last question of today's session. So, Sujata Chakraborty asks about, I hope it's visible to you.
The radiocarbon dating technique states to measurement the ratio of the two isotopes of carbon why and is not there various types of new various types of laboratories are C12 and C14 useful for any work? Of course, C12 and C13 are useful because it helps. Like for example, this not only C14, like are calibrating and we are not we are like comparing, we are getting a date when we want to check the ratio of C12 and C14. For example, the object should be of like about 5,700 years. It needs about half-life period. So the objects which are very recent, what we are doing is we used to count the amount of C12 and C14, and we take their ratios along with the ratio of the C14, and we come. So the C12 and C14, like usually C12 is constant and C13 is also constant, but the C14 is not so constant. I mean, C14 is like it degrades the half-life. It becomes whatever. For example, if we have about 5 grams of C12, and it will remain in our body as like C12. If we have C14 about 5, if we have about like 10 grams, like I'm not very good with math, I'm so sorry. If we have 10 grams, it will remain like that for a long time. And if we have 10 grams after 5,000 or like the 6,000 or 5,000, that particular half-life, it will become 5 grams. After about that, again, it will become that. But the C12 will remain constant. It will not gain and it will not lose. So that is how we can calculate that the depth. So the depth can be correct time of a death. During the death, the organism was having, or the environment about, for example, if you calculate the C12 in an organism, we can understand the ratio of or the amount of C12 that is there in the environment. So the absorption rate of C12 in each organism is different. Even the C14 is also different. So that will help us to understand about the environment. What is the environment? What is the amount of C12 and C14 in that atmosphere? Was there any chemical events or any volcanic events happened, or that can be studied?
Okay. So there's no more question today. So we are ending our session here right now.
Thank you.
And please keep an eye on our page for more updates about this lecture series. We are really lucky if we have Miss Miriam Collins with us in this series of dating, science and archaeology again. And ma'am,
anyway, thank you for invitation, and I'm so happy that I hope my presentations and my class is good. I'm not sure because I have a little very wide and I took a long time, I guess. It's like about 2 hours it's been here, and thank you for being here for this 2 hours.
no, ma'am. Okay. So we are sorry to all our viewers, and we are really sorry to our speaker for the misconsequences conducted by this hailstorm here. And goodbye, ma'am. Goodbye, everyone. Take care.
Goodbye.
Good night.
Yes. Safe. Thank you.